Okay, kids, we're going to get started here on 2.3, special products of polynomials. How about a volunteer to read my essential question there? Anybody want to volunteer to read that? Essential question.
What are the patterns in special products?
What are the specials of the patterns of special products? Okay. What are the patterns of special products? We're going to have a minus b squared. We're going to look at a plus b squared. We're going to look at a minus b times a plus b. But in any situation, kids, we've already been exposed to multiplying polynomials. And I think you guys have a really good understanding on this. So when we go through this today, we should be in pretty good shape for it, all right? So that said, let's get rolling with this right here. We're going to look at a plus b, a minus b, a plus b squared, and a minus b squared. Okay? So right here, goals-wise, first one says we're going to use the square of a binomial pattern. Okay? We're going to use the square of a binomial pattern. We're going to use the sum and difference pattern. And we're going to use special product patterns to solve real-life problems. Okay? So I think this section will be kind of short and to the point, honestly. So here we go. Guys, I don't know if I really need more vocabulary, but a binomial is a polynomial of how many terms again? 2 terms. Okay, so an example of a binomial might be, like, I don't know, 3x plus 6. How many terms are in that polynomial? What's the first term? What's the second term? What degree is that polynomial? Degree 1. What's the leading coefficient up there? What's the constant term in that? 6. Very good. You guys are rock stars. Okay. So let's get this first core concept down. I want to talk about this right here. It's the square of a binomial pattern. Kids, sometimes when we multiply things together, we've looked at stuff like, I don't know, you don't need to write this down. We've looked at like 3x plus 6 times x minus 2, and you've applied FOIL method really well to solve that. But sometimes when we multiply things, our first binomial might be exactly the same as the second binomial. And there's tricks to save you time on this right here if you don't want to FOIL out completely. And I'll kind of show you this right here. So that's kind of what we're going to talk about in this first example. This first core concept is titled Square of a Binomial Pattern. Okay? It says, what if I take a plus b and square it? It means take a plus b times what, kids? Okay, so what this means is to take a plus b times a plus b. And we'll look at an example here in a second, kids. But if I multiply this out as our FOIL method, what would the a times a get us? A to the second. Then the a times the b would be what? Just plus ab, right? Okay, and then we got to take b times a. Now guys, when you have multiple variables up there, I always would encourage you to do this. Multiplying in alphabetical order. So if I'm multiplying b times a, I should probably call it what? ab again, right? So another plus ab. Plus what, kids? Turns out right here, how many ab's do you have here, kids? Okay. This is the rule right here. It says the following. Okay. A plus b squared is always going to be this right here. So what they're saying is if you know what a is and you know what b is, you can simply plug your values in. Okay? So let me give you an example. Suppose I had x plus 7 squared like this. If I didn't want to write down x plus 7 times x plus 7 and apply a FOIL method to this, we could do this the following way, kids. All right? In this case right here, x is kind of like which variable in our formula here? And 7 is kind of like the b value. All right? So if I wanted to follow this square of a binomial pattern, in this case square of a plus b squared, I could just simply plug x in everywhere where there's an a, and 7 in everywhere where there is a b. So guys, what would this first term be under this example? X squared. Okay, let's think about the next one. Plus 2 times A times B. That'll really become 2 times what? X times 7, right? But guys, think about this. A and B right here would be 7x, wouldn't it, kids? 7x times 2 would be how many x? And then plus b squared, or 7 squared, what would that be?
49.
Plus 49. Now guys, again, if you see the shortcut, take it. All right? But could I still have written x plus 7 times x plus 7 and FOILed out if I'm more comfortable doing that? I absolutely can. All right? Well, guys, here's a question for you. If a plus b squared is this mess right here, let's see what a minus b squared would be. So as an example, this would really be the same as a minus b times a minus b if I squared it, wouldn't it, kids? So we have one binomial times the exact same binomial, don't we? So help me out. What's the a times a going to get me again, kids? Absolutely, a squared. All right? Be careful on this next part. We're taking a times b, but the a is positive, the b is negative. So would this be plus ab or minus ab? Going to have a minus ab here. Okay, right in here. Inside terms. What's that going to be? Minus ab. Okay, careful on the last part. We've got negative b times negative b. Talk to me about the product of two negatives again. Yeah, it's a positive what here? Any alike terms when I get to those first 4 terms foiled out? ABs. How many ABs are we subtracting there, Allie? So this is now a squared minus 2ab plus b squared. Oh my gosh. Guys, isn't that pretty similar to this one up here? The only difference is instead of having a plus 2ab, we now have a what? Okay, so let me give you an example here. Oh, let's pick on this a little bit more. Let's say we've got 2x plus 3. I'm sorry, 2x minus 3 to the second power. Now again, could I write out 2x minus 3 times 2x minus 3 and FOIL that? Okay, let me just do that real quickly. Let's see what the answer would be, and then we'll come back to maybe the shortcut here. So if I had 2x minus 3 quantity squared, that's what this would represent. Quickly, FOIL. 2x would be 4x squared. How about 2x times negative 3, kids? This would also be negative 6x, wouldn't it? Plus 9, right? Which would make this, in the end, 4x squared minus 12x plus 9. Okay? Now, is there a little bit of work involved in this? There is. Okay? But under these rules of squares of binomials right here, we could just simply do it in one step. Okay? What would you consider your a value to be in this 2x minus 3, kids? 2x, right? And what would you consider b to be? Okay, so here we go. What's a squared going to be? In other words, what's 2x times 2x? 4x squared. Okay. Okay, so let's do this. What's 2 times, this is going to be a minus sign now according to this. What's 2 times 2x?
4.
So 2 times the a value of 2x would be 4x. 4x times 3 would be... And then what would b squared equal? 3 times 3. Okay, did that match what we already knew foiling out? Okay. Now again, if you'd rather FOIL stuff out, go for it, all right? But if you can make the connection here, then you should be in pretty good shape, I think. So that's the core concept here of the square of binomial pattern. Oops. So let's jump to the second page here quickly. I want to make sure everybody have everything down on that first page.
Nope.
You want to get that from someone when we get done here, Gage?
Yeah.
You all right with that? You've got notes there, right? Attaboy. All right, here we go, page 2. Here's what we're going to do. Let's try one together. Let's do this 2x plus 6 squared, which means, again, 2x plus 6 times 2x plus 6. Now, again, if you want to FOIL that out, feel free to. But, guys, we know that rule now, which says this would become a squared plus 2ab plus b squared if we want to do that. Okay? So what am I really going to replace a with here if these are exactly the same? 2x. So 2x squared would be, wouldn't that be 4x squared, kids? Okay, and then we're going to go plus, all right, 2 times 2x times 6, which would be 2 times 2x times 6, which would be 24x. Yep. And then plus b squared on the end. What's that going to be?
36.
Okay. So you guys take a minute and try that next one over there. See what 3x minus y squared gets you. Now again, whatever you're comfortable with, all right? Whatever you're comfortable with here, try and find that in expanded form. And when you think you maybe have a solution, I'd ask that maybe you just double check with someone around you. Okay, let's try here. Anybody think they might have a solution for this first? Anybody willing to share? Sharing's optional. Anybody want a shot? All right, I'll try it. Guys, I'm going to go and say that this really means, if you're going FOIL method, this means take 3x minus y times what? Yep. And I could FOIL this out the way we have in the past. Okay? But by that new rule, is this a sum or a difference right here? So this would be the same as a squared minus 2ab plus b squared. Okay? So if I want to, I could let a be the 3x and I could let b be the y part to fill in here. So what would a squared get me? In other words, 3x times 3x. 9x to the what? Put your minus sign in here. Then 2 times a times b. What's 2 times 3x, kids? 6x times your b value, which is what? So the middle term is going to be minus 6xy. Whoops. I don't know why that did that. Plus b squared. What are you going to replace the b squared with? Y squared. Okay? Now, if you would have FOILed this out, this is what you would have gotten. I'm just curious, how about a show of hands? How many had 9x squared minus 6xy plus y squared? Okay? Quick question here. If you don't like this method, can you still FOIL? How many of you guys are still going FOIL route? I'm just curious. How many of you guys are going shortcut route? Okay, does it really matter? No, I'm just saying the more you get used to this. Now, what I will tell you is this. Being able to see this right here as a product of the same binomial, that's going to help you moving forward when we get into factoring things. But right now, Just make sure you can get to an expanded form here and feel good about it, okay? So if I have a plus b squared and a minus b squared, those are some examples. Questions about that at all? No go. All right. All right, next one then. Here we go. This is called a sum and a what, kids? Okay, check this out. First binomial is a plus b. What do you notice about the second one? Okay, are they exactly the same? So it's not a plus b squared and it's not a minus b squared. We say that these are conjugates of each other. And I'm not going to worry about that word too much right now. You'll get to work with that more later on in different things. But guys, if you ever have a sum and a difference, you have a and b are exact same terms, but one's addition and one's subtraction. This one here is pretty cool. This will save you time. But by rule, let's just factor this out. So if I had a plus b times a minus b, kids, here's what you end up with. What's a times a going to get you? What's a times a going to get you for this rule? A squared. How about the a times the negative b? Minus ab. All right, this is where stuff gets really cool. Inside terms. Is that going to be positive or negative for that inside term, kid? So plus ab, right? How about positive b times negative b then? Okay. Take a look at your middle terms right here, kids. Take a look at your middle terms. In that, your middle terms, kids, what's going to happen to a negative AB and a positive AB? They're going to cancel. So the only thing I'm really left with is a squared minus what? Okay, so this is a pretty important one. I'm going to put a star by this example because I really think kids, a lot of times they just keep foiling stuff out. Oh, what's going on? Frozen. Come on, Elsa. There you go. Come on, Elsa. All right, never mind. Not funny. I'll move on. What's that?
Most of us don't have children.
Oh, but I would have thought most of you were young enough to see Frozen the first time, right?
No.
You haven't seen it?
Are you okay?
Okay. Me?
Yeah, Sam.
Oh.
Yes.
Yeah?
Frozen's awesome.
It's good stuff. I like it. I love all of this. The Toy Story movies are my stuff. Honestly, Toy Story 3. Toy Story 3. You guys know what movie I'm talking about?
Yeah.
The part when they're in the incinerator and going down. I thought they were dumb. I was like almost tears on my eyes crying. And then the big claw comes and saves them. I was like, yes. It's good stuff. See you
Juniors, with
later.
last names beginning L through Z, please report to the upper gym at this time for photos. Juniors, last names L through Z, please report to the upper gym.
Okay, let's try this right here. 2x plus 4. Guys, here's the deal. I'm not squaring stuff, but what do you notice about the terms in each binomial? A and B are both the same, but are the signs exactly the same? Okay, I love this rule right here because you know in the end your answer is going to be simply what? It's going to be a to the second minus what? Okay, now if you would FOIL this out, what's going to take the place of a, kids? What is 2x all to the second power? 4x squared minus, what's 4 times 4 going to be? There it is. Okay? And the reason that works, guys, take a look at your outside terms. What would 2x times negative 4x make? Positive or negative? It would be negative 8x, right? And how about your inside terms, kids? What's a negative 8x and a positive 4x going to do in a situation like that to each other for that middle term? It's just going to fall out. So real quickly, I'll do it quickly. X plus 3. Right down here, show of hands. What's the answer to this when you expand it?
X squared minus 9.
X squared minus 9. Okay? That's a good one. Okay? So in fact, what I want you to do, I screwed up in the notes down here in example 2, put a parenthesis around the A out front there. Okay? You guys do those two real quickly. I'm going to give you about 31.4 seconds to complete both of those.
That is bad.
It's 10 pi seconds.
I got no idea what
Just point only. The same way we're doing from the last section.
oh,
If you ever have a situation where you have to be plus 2 times A minus 2, what is it that we times A we do the quotient? Now what would these terms do to each other? So I'm saying is this, when you see a pattern, and you're like 2x plus 4 and 2x minus 4 like this, the same terms, right? One side's a plus, one side's a minus. It's just the same term squared times the term squared. So what's 2x times 2x? 4x 2x. 7, right? Then that's a minus sign by this. And what's the first term? 16. That's all you're doing, okay? All right, so real quickly, this next one, the a plus 8, a minus 8. You notice right here that the terms are pretty much the same, except you have opposite signs between the two binomials. What's this going to be real quickly? Yep. Careful on this one. What's this going to be? Good? Hey. Now, guys, I love this stuff because here's why. You can start applying rules like this to mental math. And one of the things that I see right here is this. Use special product patterns to find, we can do this mentally in our head using this, okay? 48 and 52, really close to what value? What nice value to probably work with? 50. Do you guys agree that 48 is the same as 50 minus 2? Okay. So this is like 50 minus 2 times, how would I rewrite 52 as something with a 50 in it? Holy smokes, you guys. Check this out. If I wanted to know what 48 times 52 was and thought about it mentally, let's suppose you were on Who Wants to Be a Millionaire, and you had to do this mentally in your head. And they gave you 31.4 seconds to get an answer, a final answer. Watch this right here. Isn't this like, aren't the terms kind of the same, just the signs are opposite? Couldn't I do 50 squared minus 2 squared? What is 50 squared?
Exactly, that's the problem with that.
What is 50 squared? 2,500, right? What's 2 times 2? Now, guys, if you could think of it like that, yeah. 2,500 minus 4 is what? 2,496. There you go. Now, guys, if you ever get on Who Wants to Be a Millionaire and they ask you this question and you have to answer it in a hurry, I'm going to guess you might phone somebody. Who are you going to phone?
You?
Oh, me? Would you share with me if I gave you the right answer?
No.
Okay,
Maybe I'll
then.
give you like $10,000.
$10,000?
I'd give you the Hertz donut that you
Yeah, I was just going to
How about
say
you
that.
just give me free Hertz donuts for a lifetime when we got a deal?
I feel like you would
But
eat
that's
more than
really
$100,000 worth of donuts.
Think so?
That's $1 million donuts.
I might look like Homer Simpson when I'm done too. Let's have you guys try one. Let's do this. How about 32 times
We sell Hertz donuts.
28? Okay. What value are you probably going to work around with 32 and 28? Yeah, so you're going to call the 32 what? 30 plus 2 times what, kids? Okay, go. Ooh, I see the terms are the same. Opposite signs. Guys, without a calculator and applying that rule of sum and difference pattern, what's this going to equal? 896. Okay, 896. Now again, guys, could I have foiled that out if I wanted to? 30 times 30, 30 times negative 2? I could. Guys, if you run into troubles and all else fails, what can you resort back to?
Foil.
Yes. Okay, if you're not sure that you have an answer right, revert back to foiling stuff, okay? All right, questions on the second page at all? Well, let's get this next example done, and I'm going to get you going with a short online page. Don't forget, if you didn't turn 2.2 in yesterday or today, when do I absolutely need that by? Okay. And then also don't forget to check JMC. Okay. I don't know. How many of you guys have had a science class that's talked about Punnett square before? Okay, dominant traits compared to recessive traits. Okay, it says each of two cats has one black patch gene, capital F, capital B, and one tan patch one tan patch gene T. Any gene combination with a capital B results in black patches in the offspring's fur. The Punnett square shows the possible gene combination of the offspring and the resulting patch colors. Guys, which gene is the dominant gene? B, okay? It says what percent of the possible gene combinations result in what? Okay. Well, kids, the only way we can get tan is what? The two T's down here, right? Well, guys, what percent of those blocks up there are two T's?
25.
Okay, so the first answer simply is 25%. Okay? Now it says, show how you can use a polynomial to model the possible gene combinations of the offspring. Okay? Well, here's the deal, kids. What percent are two black dominant genes? 25%, right? What percent's a combination of the black and tan gene? 50. So the way you could express this as a polynomial, there's really three types. Okay? What percent would the two blacks be for this whole square? Each square is going to represent 25%, isn't it? So they say, well, real easily put, you guys agree that this is like b plus t times b plus t?
Yeah, it's like the block method.
Yeah, isn't it? It is. Okay, so here's the deal. We want to apply percentages to it. And what you would get here, kids, if you did this would be really the following. Isn't this like b plus t to the second power here, kids? Okay, now what you need to do here, kids, is this. First thing I would do is multiply this out, and now we're going to take each part of the polynomial times the 25% in each part, okay? So here's what you would see. What's b times b going to get you? What's b times t going to get you on the outside? But how, well, it would be b times t, right? But how many bt's are we going to have, kids? And then finally, plus what on the end, kids? You could write it out like that if you wanted to, but what they're going to do is they're going to say is then that each b right here has what percent of chance of happening here. So they're going to multiply every term by 0.25. So what they're really saying is, well, this is like 25% would be like 2b squared. Or I'm sorry, b squared, because that's like capital B times capital B, isn't it? Okay, there's a 25% chance of that capital B times capital B happening within the Punnett square. That's this right here, right? Guys, what's 0.25 times 2? In other words, 25% times 2. What percent would that be? 25% times 2 would be how many percent? 50%. And as a decimal, that would be like 0.50 BT. Well, kids, if I go back to this chart right here, how many 25% blocks were BT? 2 of them, which would really yield what percent? 50%, so that's where that comes from. And then you're going to have a plus 0.25 T squared here. Okay. So again, I'm not too concerned about what's going on here. I just want you to see the relationship to like, and Andrew, you said it perfectly right there. This is like the box method for multiplying these, right? It just happens that we're doing B plus T times B plus T. We're multiplying the same binomial together, okay? All right, so guys, again, I tell you, there's shortcuts here. Explore them this weekend when you get a chance to